In this video, we will discuss higher order derivatives. The derivative of a function is also a function. So in many cases, we can take the derivative of this function as well. The derivative of f prime is f double prime and is calculated by taking the limit as h approaches 0 of the quotient f prime of x plus h minus f of x divided by h. The function f double prime is called the second derivative of the function f, and f prime is often called the first derivative. Assuming differentiability of derivatives, we can continue taking higher order derivatives as long as we like, finding f triple prime, f quadruple prime, and so on, up to some fn, the nth derivative of the original function. Find the derivatives of all orders of the polynomial function f of x equals x to the fifth minus 3x to the fourth plus 4x cubed minus 2x squared plus x minus 8. F prime of x is 5x to the fourth minus 12x cubed plus 12x squared minus 4x plus 1. This is just taking the first derivative of this function, and we're pretty used to doing that by now. F double prime of x is then taking the derivative of the first derivative, and that's going to be 20x cubed minus 36x squared plus 24x minus 4. This is just going to get simpler as we go on. Every time we take the derivative of a polynomial, it loses one power. So f triple prime is 60x squared minus 72x plus 24. f4 is 120x minus 72. f5 is 120, and f6 is 0. And for all n greater than 5, fn of x is 0. What is the third derivative of the function y equals x to the 2/3, and what is its domain? So we take each of the derivatives. Y prime if y is x to the 2/3, then y prime is 2/3 x to the negative 1/3. Y double prime is 2/3 times negative 1/3 times x to the negative 4/3, or negative 2/9 x to the negative 4/3. And y triple prime is negative 2/9 times negative 4/3 times x to the negative 7/3, which is 8/27 x to the negative 7/3, or 8/27 x to the 7/3. The domain of the function y triple prime is the set of all real numbers except x equals 0. Note, this is also the domain of y prime and y double prime, and will be the domain of yn for any subsequent derivative. Find the second derivative of the function y equals 2x squared plus 3 to the 3/2 power. Applying the general power rule, we have y prime equals 3/2 times 2x squared plus 3 to the 1/2 power times 4x, which is 6x times 2x squared plus 3 to the 1/2 power. Then, using the general power rule and the product rule, we get y double prime is 6x times the derivative of 2x plus 3 to the 1/2 plus 2x plus 3 to the 1/2 times the derivative of 6x, which is 6x times 1/2 times 2x squared plus 3 to the negative 1/2 times 4x, plus 2x squared plus 3 to the 1/2 times 6, which is 12x squared times 2x plus 3 to the negative 1/2 power, plus 6 times 2x squared plus 3 to the 1/2 power, which is 6 times 2x squared plus 3 to the negative 1/2 power times 2x squared plus 2x squared plus 3, which is finally equal to 6 times 4x squared plus 3 over the square root of 2x squared plus 3. An application. Recall that when we first introduced the derivative, we talked about it in terms of the instantaneous rate of change of a function at a given time. If we let s of t be the position of an object at time t, the rate of change of the object is the velocity of the object. So s prime of t is v of t, which is the velocity function of the object. But the rate of change of the velocity is the acceleration of the object. So the derivative of the velocity is v prime of t equals a of t, the acceleration function of the object. This means that s of t is the position of the object at time t, s prime of t is v of t, which is the velocity of the object at time t, and s double prime of t is v prime of t, which is a of t, which is the acceleration of the object at time t. The distance s in feet covered by a maglev moving along a straight track t seconds after starting from rest is given by the function s of t equals 4t squared, where 0 is less than or equal to t is less than or equal to 10. What is the maglev's acceleration at any time t? Since the position is given by s of t equals 4t squared, the velocity is therefore given by the function s prime of t equals v of t equals 8t. Then the acceleration of the maglev is given by the function s double prime of t equals v prime of t equals a of t equals 8. The acceleration of the maglev at any time t is 8 feet per second squared. A ball is thrown straight up into the air from the roof of a building. The height of the ball is measured from the ground as given by s of t equals negative 16t squared plus 24t plus 120, where s is measured in feet and t in seconds. Find the velocity and acceleration of the ball 3 seconds after it is thrown into the air. The velocity of the ball is given by the function v of t equals s prime of t equals negative 32 plus 24, negative 32t plus 24. So the velocity of the ball after 3 seconds is v of 3 equals negative 32 times 3 plus 24 equals negative 72 feet per second. The acceleration of the ball is given by the function a of t equals v prime of t equals negative 32. So the acceleration of the ball after 3 seconds is a of 3 equals negative 32 feet per second squared.